We implement and evaluate different methods for the reconfiguration of a connected starting arrangement of tiles into any desired target shape using only a single active robot. Our purpose is to reconfigure a structure as shown in the two images. We demonstrate an algorithm that involves the use of histograms to translate the starting configuration into the target configuration. The algorithm consists of 3 phases as seen in the diagram. In phase 1, the starting configuration CS and the target configuration CT are configured into histograms, with their bases sharing a baseline shown by the gray dashed line. In this case, CT is shifted down and CS is shifted up. Once the histograms are created, HS is translated into HT during phase 2. Finally, phase 3 is just a reversal of the histogram process to recover CT. A simulator was created in MATLAB to test the algorithm. Using the simulator, we compared the performance of the algorithm, dubbed CH2C, to 2 other algorithms used in prior work, the grow largest component and minimum weight pair matching expand algorithms, as well as a TSP-based solution. For the first round of tests, thousands of maps that could be clearly separated by 1 or 2 lines, as shown on the left, were used for comparison. We also assumed that the cost of picking up and placing tiles is equal to the cost of robot travel. The plot shows that CH2C performs much better than the other 2 algorithms and exhibits a strong linear relationship with the TSP cost. CH2C was designed for configurations that did not have initially overlapping bounding boxes. If there is overlap, CH2C no longer performs better than the other 2 algorithms, although it still has a 100% completion rate. Other tests were performed include the number of pickup and drop-off pairs generated by the algorithms, as well as the impact of changing some of the CH2C characteristics. For a hardware demonstration, we utilized the Billy robot platform. This inchworm-type robot moves on tiles and can pick up and carry 1 tile at a time. Using the Billy bot forces us to follow the structure connectivity constraint, as it can only walk on tiles due to its feet's design. Despite the limitations of the platform, it is flexible in terms of movement and can even translate a structure with very limited space available, as shown in the video. Here's a demonstration of the Billy bot using the proposed algorithm to reconfigure a structure. There are several differences between the robot and the idealized tile mover considered by the algorithm, including orientation and the feasibility of pickups and drop-offs. As a result, the moves get the Billy bot to its target locations had to be curated, and it also required manual assistance with picking up and placing tiles in many instances. Future work includes augmenting the algorithm to consider the limitations of specific hardware when planning, as well as the extension to 3D structures. Thank you.